Okay, so we will try to explore a different ML terminology, and not in technical terms. I was saying, I'll be explaining in simple terms. This is just to understand our mathematical techniques. When I'm teaching about matrix decomposition, I'll be frequently saying this is used in principal component analysis. When I'm talking about optimization, I will be saying we will be using these optimization techniques in linear regression. Okay, right? When I'm teaching you about eigenvalue, eigenvector, that is used in PCA. So to link our explanation, to make our understanding easy, I'm just going to explain about these ML algorithms in simple terms. Let's see this. So first one, linear regression or in specific regression analysis. Okay, in specific regression. What is this linear regression? Right? Imagine you are saving money every month to buy a bike. You want to purchase a bike, you are saving money for that. From January or from this June or July, you want to save money for that. Linear regression is like guessing how many months of saving will get you a new bike. Okay, so if I start saying from today, how many months of my I should save so that I can purchase a bike. I hope you understood. I'm not going to technical. What is that equation? What is that line? Y equal to mx plus c, right? Or what is simple linear regression, multiple linear regression? No. Regression means it is helping us to identify a quantifiable number. It is helping us in a number, right? So this is the best example to understand. You want to save money for purchasing a bike. How many months do I have to save? That number of months is given as the output from this regression techniques. Now you can apply for any term. I want to purchase a land in Hyderabad, somewhere in Hyderabad. So based on historical data, what will be the price? Today, if I go and purchase, what will be the price? So predicting it based on the past data, right? I hope you understood. So almost all the predictions can be done using this linear regression. These are just, so when I say regression, you assume it's a machine learning model which is helping me to identify, or it helps in prediction. Okay, next, logistic regression. What is the difference between linear regression and logistic regression? Difference here, you see. Imagine you are deciding if it will rain or not based on the clouds. Okay, so this logistic regression will help us in predicting yes no outcomes. Here it is giving me a number as output, which can be anything, 100, 1000, 0.5, any number. It can be anything. See, how many months do I have to save? Okay, right? What will be the price of the land? It's a number, price again in number form. So linear regression helps me in predicting a output which is a variable, which is not fixed. But in logistic regression, I may do prediction and the output will be only two, either yes or no. So if you have some problem where you want to find out yes or no kind of an answer, you have to go for logistic regression. Okay, I hope you understood the difference between linear regression and logistic regression. Here in the logistic regression, you are deciding if it will rain or not based on the clouds. Okay, so this will help us in identifying yes or no output. So these two terms. Next, decision trees. What is this decision trees? How it is built, what technique it is used? No, just understand this. Think of making a decision like choosing what to wear based on the weather. Based on the weather, you want to choose what to wear. If it is summer, some light clothes. If it's winter, some jacket or some mask kind of a thing. You want to have a sweater kind of a thing. So you want to make a decision. Suppose you want to make a decision choosing what to wear based on the weather. Based on the weather, there is something existing outside. Based on that, I have to decide here. Okay, so decision tree helps computer make choices by asking series of yes no questions. So it's simple. In decision tree, it asks us many yes or no questions. Is the climate, it is raining, yes or no? If it is yes, again, is it light or drizzling or heavy rain? So that way it will ask you questions. Okay, Is it hot or cold? If it is cold, is it rainy or just cool breeze? So it will ask different yes or no questions. So when you want to make such kind of a choice, you have to use decision trees. Next, support vector machine, SVM. Okay, maybe in another course you have to study all these things in detail, but here we are focusing only on the mathematics part, mathematical foundation or mathematical background underlying these algorithms. So SVM, support vector machine. Think of separating apples and oranges in a basket by drawing a straight line. You have a basket full of some fruits, apples and oranges. You want to separate them by putting one more card, one separate line you want to draw between them. Okay, but it is all mixed. So SVM helps us to find the perfect line which can separate all those fruits. Apples are there, oranges are there in a basket, but they are they are not in a proper format. So SVM helps us in separating them or drawing a line between those fruits.
आपका दूध बना दूं ठंडक निकाल के.
Next, random forest. Some noise. Yes. What is random forest? All these are ML algorithms. Random forest. Think of asking advice from many friends. You are asking advice from your friends. Okay. And combining their answer. Simple. Random forest means you want to make a decision. Instead of using your brain, you are giving that task to, you are giving asking your friends. Please tell me, you can ask them, what is your opinion in this? Like this, collecting different opinions, combining them, and whichever has been more popular, that is your final decision. So random forest is such kind of an algorithm where you ask multiple people, get their opinion, whoever voted more. Like suppose you got placement in TCS, you got in Infi, or you also have in CTS. You do not know which company to join. You ask some 10 people, whichever gets more votes, that company you can join. That is random forest. So we have some problems of that kind, right? So that is simple explanation about random forest. Naive Bayes. This is one more algorithm, Naive Bayes in machine learning. What is its use? What understanding of this? If you guess the flavor of the candy, of the chocolate, with the color, you are making prediction based on what you know. Okay. Yes, SVM and random forest. See, SVM in support vector machine, if you are separating, you have a basket full of apples and oranges. You want to separate them, draw a line between them. Okay. SVM helps us in drawing such line, in classifying the things. I want to have all the apples aside and oranges aside. I want to have classification. Separate them. I want to separate them. So SVM helps us in drawing a proper line between both these apples and oranges. Whereas random forest, here it's kind of a decision tree. Okay, you want to make a decision. Instead of using your brain, you are giving that question or you are giving that challenge of making a decision to 10 of your friends. They give their advice. Whichever advice gets more more votes, or whichever has the more popular answer, that is your final choice. So you're making a decision. To make decision, we use random forest. Okay, like I told example, like you have you got three company offers. You have TCS, Infosys, and also you have CTS with you. 3 offer letters you have. You want to join. So which one should I join out of these 3? You have to make a decision. It is difficult. So you give this task to 10 of your friends, ask them their advice, combine their advice, whichever is more popular, that is your choice. So combining their answers and using the most popular answer. If many give voting to TCS, you join TCS. That is random forest. So in ML, we have in real world, we have some problems where we need to make a choice. we can use random forest. Naive Bayes, a typical kind of an algorithm in machine learning. What is this? See, if you guess the flavor of a chocolate by its color or candy, by seeing if it is orange candy, you believe that it's an orange flavored one. If you see a dark one, you may assume it is brown, you may assume it's a chocolate one, right? If you see something yellowish, you may assume it is mango flavored, right? If you are guessing the flavor of the candy by its color, you are making a prediction based on what you know already. Same way, naive Bayes does the same thing with mathematics. It predicting outcome based on past information. It has some knowledge. With that knowledge, it will try to guess. Okay, so there are some similar problems in real world where we need to make a guess based on the past data. Okay, maybe the best example can be this score prediction of Virat Kohli in today's match. So based on his historical data, with what I know, how he has played in ICC tournaments, I may be guessing how much he will be playing, how much score he will be making today. Okay, that is naive Bayes. Next one is k-means clustering. So it's like it is simple as sorting. Clustering means grouping similar elements. Okay, so it's like sorting your toys into groups without being told the categories. So you have a lot of toys in a basket. You want to group them, all red colored ones into similar one in a single package, all blue color ones into single packet, or all small cars into separate group, small toys, dolls into separate one. You want to separate them, right? So k-means clustering means grouping together, grouping the related content together. Okay, so this algorithm finds toys that are alike and puts them together. Clustering, clusters, we are forming different clusters. You have a lot of balls in a basket, red color balls, orange, blue, black balls exist. You want to separate them, form all the colored, similar colored balls into a group. That is clustering. How it is done? That is ML algorithm. We'll see that. K nearest neighbors, KNN. Okay, nearest neighbors. See, I will explain it multiple times. If you don't understand, please ask me. KNN, nearest neighbor. First line you will understand. It's like finding your favorite book by asking friends for recommendations. Okay, I want to decide. I want to finalize one book. I want to form a favorite book. I want to prepare. I want to have a favorite book in my mind by asking friends for the recommendations. I'll ask them, which book do you think is more suitable for me? Friend 1, friend 2, I will ask. Friend 3, I will ask. By their recommendations, I will decide my favorite book. Okay, so here the challenge is KNN finds the closest neighbor to make the predictions. So friend 1 might give me one book, friend 2 might give me another book, friend 3 might give me another book. But whose recommendation should I consider? So nearest neighbor. KNN algorithm helps me in identifying who is the nearest neighbor. That neighbor who has similar characteristics like me, so that his recommendation I can consider. Okay, so that is about KNN algorithm, right? So this is little typical to understand for you. Maybe at this point, if you are new, KNN helps us finding the nearest neighbor for us. Why we need neighbor? That neighbor's recommendation are the most useful for us. Next, PCA, principal component analysis. I have been talking all about this PCA, right? So in principal component analysis, just a second. In PCA, what is PCA? Again, you can easily understand this principal component analysis. Dimensionality reduction. Matrix size is very big. I cannot play with that huge data. I want to reduce that matrix size. For that, we use PCA. But in simple terms, if you understand, think of PCA as packing a suitcase. You're trying to pack a suitcase. You have a lot of clothes with you. PCA helps you fit the most important pieces into small space. You have a suitcase, you have a lot of clothes with you. Some are important, some are not important. Space is limited. PCA helps you to fit the important clothes in smaller space by such that it utilizes small space. Now, if I talk about machine learning in terminology, technical terminology, you have a large data set, large matrix size, but I have less space with me, less size with me. Okay, but I have a large data set. Matrix size is very big. I cannot play with that huge one. What can I do? I should do the compression of data. I should reduce the size of the data such that it fits in smaller space and the important information is carried. Maybe we had a matrix here of 4 cross 4. Okay, so if all data is important, not all is important, some are important, some are not important. I will try to compress the data. I should not use the word compress, but for now you understand. I will try to compress the data into only a 2 by 2 matrix or 2 cross 4 matrix. Only these 4 rows became 2 rows now. Only 2 rows. But these 2 rows has the most important information about that particular data. Suppose it was some placement related data, these 2 records are sufficient. So we are trying to compress the data. That's what PCA is like. Packing suitcase. You have a lot of clothes, some are important. This PCA will help you fit those most important clothes into smaller space. So less space is occupied and the important clothes have come with you in the suitcase. That is PCA. Again, how it is used in machine learning, I hope you understood. Gradient boosting, right? So yeah, I am playing a video game. Any game you play, generally when you play it for first time, you make mistakes because you don't know the rules. With experience, you learn the rules, and with experience of making mistakes, next time when you play it better because you already made few mistakes in the previous match. Same, that is gradient boosting. See, imagine playing, you're trying to get better, you're trying to getting better at a video game by fixing small mistakes each time you play. First time you played, you don't know the rules. Second time, you knew little rule. Third time, you made few mistakes, you overcome them. Fourth time also, you made another kind of mistake, you also overcome it. Similarly, when you play for 8th time, 9th time, you overcome those mistakes one by one. So gradient boosting improves predictions by learning from the past errors in the small steps. Okay, so it's like when you play a game, you try to improve it at each step. Right. Next, again, little I will talk about regression here. I will talk about machine learning here. Why is this gradient? How is this gradient boosting useful? See, I formed a model 10x plus 0.72. I said this is the model for doing prediction of the bike price, Honda Activa price for the next version, which is going to come next year. This will help us in identifying it. Okay, but maybe this 10 is not accurate. This 0.72 is not accurate. If we can little improve, maybe I'll try to make it 10.1x plus 0.72 and check how it is performing. Or I'll make it 0.99x plus 0.72 and check whether it is matching with the real price or not. So you're making small corrections at each step and improving your model. Oh no, when you do this, you could see no, it is going in wrong direction. Then you will fix this to 10x only. You will try to change this now. You will make it 0.73 or 0.71 or 0.74. You will observe that when I'm increasing this, price is becoming closer to the actual value. Then you will keep increasing 0.74, 0.75, 0.76 and so on. Understood? So one parameter you are fixing, that is 10. Other one you are trying to increase and decrease. When you're increasing, it is performing better. Okay, yes, it is matching with the real output. When I'm decreasing, no, it is not working. So leave that decreasing part. Only increase 0.01, 0.73, 0.74, 0.75. Slowly increase it. At certain point, when you increase more, it is again going beyond it. So you're making small corrections and forming a better model. That is gradient boosting. Next, neural networks. Okay, so this is again from here we talk about human brain. In our human brain, we have a lot of cells working together to help us learn, right? There are a lot of neurons in our brain which helps us to learn, right? So neural networks are computer versions helping machines to learn from examples. How do you know that if you touch a heat pan or a hot vessel, it will your hand will burn? You know that. How you know? With the learning, with example. You touched it before, you felt heat, your hand, your finger got burned little. Second time you will not touch it because you already know. You have learned that. With experience, you have learned it. That is neural network. So learning from examples, that is neural network. But there is little version. What is CNN? People talk about convolution neural network. What is this? So the difference here is, again, little about image processing here. Imagine your brain recognizes face in photos. You open an old album, you could see your school batch group photo in that. Then you will try to identify who is this fellow, what is his name, what is his name, what is her name. You try to recognize them. How you do? Because that previous information is stored in your brain and you are processing your image information, pictorial information you are trying to process in your brain, and you are trying to guess or trying to identify who is that fellow. Maybe you are trying to identify his name, right? So CNN mostly talks about image processing. See, CNN are specialized neural networks that helps computers to see and understand images. Convolution neural networks are used in image processing, computer vision. Why? How does it works? It does processing in the brain by seeing the images, trying to recognize the person by seeing the image. How your brain generally does, that was CNN does. Next, RNN, recurrent neural network. It is a similar one. Think of remembering a story by recalling previous sentences. Suppose you already watched a movie long time back. There are a lot of steps in that movie. Your friend is telling you, after telling you third step, immediately your brain is telling that yes, this is the fourth step. I remember now. So based on the previous steps, previous sentences, you are trying to recall your current step, right? Same way, RNN help computer to understand sequences like text or time series data. Sequences. So what could be the next step? When I am saying hello, it's obvious that next I will say good evening, because that's what the history says. Hello, then good evening, welcome to my course, I will say. Welcome to day 1 of this online workshop, I will say. So tomorrow, when I say hello, immediately I will say good evening, I will say welcome to day 2. Day after tomorrow, I will say welcome, hello, good evening, welcome to day 3. Right? So on 4th day, when I say hello, good evening, you will definitely expect that I will say welcome to day 4. So RNN is that kind of thing. I'm talking in a lighter way in simple terms, but these are not simple algorithms. They're little complex deep learning algorithms. But to understand what is RNN, what does it does, how it is linked to mathematics, for easy understanding of our mathematical concepts, we are discussing this. Autoencoders. See, autoencoders is very simple. You have a big picture, big image, you're crushing it, making a small image, and then expanding it back. Okay, because sometimes we do it, generally we do this. You have a big maybe a piece of cloth is there, or a big document you have with you. You cannot store it in your bag or somewhere. If you can fold it and compress its size, you can fold it 4 or 5 times, it becomes a small piece. Then you can put it in your pocket, or you can put that in a bag. A4 paper I cannot put in pocket. What I do, I try to fold it 4 times, I make it small, and then I put it back. It's very small. When I open it back, it's big again. Nothing is lost. For storing that A4 paper in my pocket, I'm trying to fold it. Same thing is autoencoder. You have large data with you. We cannot play with that large data. You try to reduce its size. Play with it. Again, make it back in normal size. Autoencoders. So because we have large models, large data sets with us, huge data size with us, we have to use autoencoders so that we can make our processing easy. compress that to small size, do your task, again bring it to original. Best example, to put a A4 size paper in our pocket. I cannot put it easily as it is. I am folding it 4 times and putting it. Then but nothing is lost. When I open it back, it is same. The information what was written on the paper is same. Nothing has lost. We are just reducing its size. That is autoencoders. With the help of autoencoders, we do that. Why I have to do it? Because sometimes maybe ML algorithms I cannot play on that huge data. Bayesian network. Okay, Bayesian networks is one more concept. See, think of predicting weather. I can do the prediction of the weather using linear regression also. Linear regression can tell me what could be the temperature tomorrow afternoon in Chennai. Okay, in Chennai, what could be the temperature tomorrow? I can tell me. But thinking of predicting weather by considering different factors like temperature and humidity, not one factor, multiple factors. When you use multiple factors, then we use Bayesian networks to come to that point. Okay, next. Genetic algorithms. This is not part of machine learning, but we are using genetic algorithms in solving some ML problems. So what is the genetic algorithms? Think of creating a super pet by mixing traits of different pets. Different pets are there. You want to form a super model by taking the best qualities of each of those pets and then combine it to form a super one. That's what is genetic algorithms. So it evolves solutions by combining best options over time. Take 2 pets, take their best qualities, form a new one. Then add the best quality of third pet, form another one. So like this, you do it in genetic algorithms. You try to form a best model by combining different small models. Not ensemble, kind of ensemble, I would say. Reinforcement learning. Reinforcement learning. This is one more additional field of AI. So we have machine learning, deep learning, and we have reinforcement learning. We are also going to learn some mathematics from that as well. So to understand what is reinforcement learning, it's nothing but action followed by a reward. Action followed by a reward. If you go to some zoo or some water plants or some circus, may not be, maybe circus or some water kind of parks where you see some a man is playing with the dolphins, right? So when a dolphin performs an act, that fellow will immediately put some food to it. So it is getting a reward for doing a jump or taking a slide, right? It is getting a reward. Again, it will do whatever he says it is doing, but in between it is getting a reward. When getting reward, it performs better, right? In same thing, imagine training dogs with treats. So this helps computers to learn by rewarding them for good actions and correcting mistakes. Okay, so if you want to play chess game, when you're playing a game, for every right move you take a reward for yourself. Okay, for every wrong move you make a correction, so you play it better every day, right? So best example to understand the dolphin fellow in that circus is giving food in between, rewarding for every better action. That is reinforcement learning. This is actually used, reinforcement learning is used in robotics. To design robots, we need to have this concept, because for every good action I have to reward it, so that it assumes that since I got a reward, it means I have done a right step. When it is, you see in hotels today, restaurants, we are having robots bringing us food for us, right? So it's already trained. While training, this technique is used, reinforcement learning. So these are few techniques, ML algorithm techniques, which I have explained in simple terms. So then and there, I'll be using these terms: regression, I will say; decision tree, I will say; or PCA, I will say; clustering, I will say, right? Because we are going to use gradient boosting, I'll be talking about, because we are going to learn the mathematics behind these techniques. So while explaining that matrix decomposition, I have to tell you how it is useful and where it is useful in machine learning. So these definitions, I hope you understood. I will share the recording also. So this will help us in understanding what are these techniques. If you're already a machine learning enthusiastic, already you have been learning it, you know all these techniques, that's fine. But somebody who is new, without knowing any technical, what is the use of regression? What is the use of support vector machine? That can be understood with these simple examples. Real world, simple examples which are very easy to understand. I hope you got clear idea about what are those algorithms and what is their use in real time.